Good morning, good afternoon, class. Now today we will see the concept of feature reduction. So before we start the concept of feature reduction, let us understand what is the feature. So the features are the element of your input vector, where the number of features is equal to the number of nodes in the input layer of the network. So the features are nothing but it is represent the object, okay, and in technical thing it is nothing but the input vector for your machine learning algorithm or deep learning algorithm. So we are providing this feature as a input vector to your deep learning or your machine learning. Okay, now in normal condition, what is the features? The features are nothing but, let us consider you want to develop the model of house pricing prediction system. House pricing prediction system. Okay. So what do you mean by the house pricing prediction system? On which parameter it is depend on house pricing prediction. So this house pricing prediction is depend on the number of rooms. How many number of rooms are available in that home, house area, that carpet area, air pollution index, AQS, air quality index पे आ जाता है इसको, AQS of that particular city or area, then distance from the facilities including the bus stop, then airport, railway station, okay, main market, all these things. Okay, so distance from the facilities, then economic index of that particular city, security of that particular house in that particular area. So based on that feature, you can predict the price of the house. So how we can say that the price of the house is okay. So this house price means, let us consider your house. You are saying that my house price is 25 lakh rupees. My house price is 30 lakh rupees. My house price will be the 35 lakh rupees. So how we can decide that house price? So your house price must be you have to decide on the basis of this feature. Now, when I want to develop the machine learning model or a deep learning model to predict the house price, so you have to provide this value as an input vector to your machine learning or deep learning model. What you have to do? You have to provide this value, that is feature, to your machine learning or deep learning as an input vector, and this input vector contains the number of features. So number of rooms are there, then the carpet area of that particular house, and the distance from the facilities, economic index of the city, security guard is available or not, or there are the n number of features. On that feature you can predict the house of your price. So these features are important. So another example, in last lecture we have seen how we can predict that the animal is dog or cat. How we can predict that animal is dog or cat? So there are some features. On the basis of that feature, you can say that this is a dog or it is a cat. Okay, so this dog and the cat. So how we can say that which is a dog and which is a cat? So if the length of ear is greater, then you can say that it is a dog, and if the length of ear is small, so you can say that it is a cat. Okay, then based on the height, you can differentiate the cat and the dog. Okay, so there are, let us consider 10 numbers of features. There are the 10 features. On the basis of this 10 features, you can predict that which is a dog and which is a cat. Okay, so these features are important for your machine learning and deep learning, and you are providing this your feature as an input vector to your machine learning and the deep learning. Okay, now, but why there is a need of feature reduction? Why there is a need of feature reduction? Why it is called as a feature reduction? The feature reduction is required. Why? Because let us consider in your model you have 1,000 features. 1, 2, 3 up to the 1,000 features. Okay. So when you provide this 1,000 feature as a vector to your machine learning model or the deep learning model, or the deep learning model, so your machine learning model or deep learning model maybe get confused or it not be give the proper answer. Okay. So in that case, what happens? Your machine learning or the deep learning model will not be work properly. Okay, because it not give the proper decision for predicting that particular object or predicting that particular thing. Okay, so what is the solution? The solution for this problem is that you have to reduce the feature. And how we can reduce the feature? By selecting the important features, from your data set. Okay. So here you have to just select the important feature. For example, feature number 1, feature number 3, feature number 5, feature number 81, feature number 110. These are important for prediction. So instead of taking the 1,000 features for your machine learning model, what you have to do? You have to select only 1 to 25 features. Okay, 1 to 25 features out of the 1,000 feature, and then you have provide this feature as a vector to your machine learning or deep learning model, and then your accuracy will be getting increased. Okay, percentage of accuracy of your machine learning or deep learning has increased when you provide the minimum number of features as compared to the 1,000. Okay, so how you can reduce that? So there are some way you can reduce that feature. The first one is irrelevant feature that create a noise. Okay, so let us consider you want to predict the house price. Okay, so in that house price prediction system, the irrelevant feature, what is the irrelevant feature? You can say that greenery. Okay, so that is not so important for the predicting that particular house price. So greenery is available or not, it is not so important. So you can say that you have to remove that feature, even though it is available in that data set. Okay, as a feature, so you can remove that. Okay, because you want to give the important features to your machine learning. So you have to remove that feature, that is a greenery. Then another feature, that is a economic index opacity. So economic index opacity, it is also not so relevant. Okay, it is not so relevant. I am saying that it is not so relevant, but it is a relevant, but it is not so relevant to your machine learning algorithm prediction or deep learning algorithm prediction. So you can remove that particular feature or reduce that particular feature. Okay, so these irrelevant features you can remove from your machine learning, from your data set. So that is the irrelevant feature you can remove. Then redundant features. Okay, so redundant features means that feature that are available in multiple times. Okay, so you can remove that features also. Okay, so irrelevant feature, redundant feature you can remove from your data set, and using that you can reduce your feature from your data set. Now, what is the relationship between the features, or you can say that the variable, and the performance of your machine learning algorithm? So this graph is show that when the variable, or you can use that as a feature. Okay. So this variable or the features, you can say that related to your performance of machine learning or deep learning algorithm, it say that the performance of your machine learning has been get increases when there are minimum number of features. So as you are increasing the number of features, so your performance is also get down. Right? Are you getting? Okay. So what it is indicating? It is indicate that, let us consider it is indicating the number of features. So this is the number of variable 1, then 2, then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. Okay, so there are n number of features are available. Okay, so this if your features are minimum, so in that case you can say that this performance is get increases. Okay, the performance is increases if you have only the 5 features, but your features, as your feature has increases, means X number of features are like 6, 7, 8, 9, 10, 11, 12, 13. So it shows that your performance is get down. Okay, so for that performance, to maintain the performance of your machine learning algorithm, you have to use the minimum feature, and for that you have to reduce your feature. Now, what are the types or what are the methods we are used to reduce the features? So to reduce the feature, there is a feature reduction, that is a type 1. So in this feature reduction type 1, let us consider you have a feature. So this is indicating your feature. So I just, okay, so these are my F, or you can say that it is a D, my data set. You can indicate that it is a D or F. Okay. So D or F, so this is a data set, and how many features are there? There are X1, X2, X3, up to Xn. How many features are there? There are Xn features are available. Okay, so out of this Xn, you have to select a important feature, and you can say that now this is my new data set. According to your problem definition, you have to select only D dash, that is a X2, or you can say that this is a X1 dash, X2 dash, X3 dash, and X5 dash. Okay, so this is your D, that is a data set, this is your D, that is a data set. Okay, and this D is nothing but your original data set, and in that original data set, how many features, how many variables are there? There are the Xn variables. But I reduce my data set and say that it is a D dash, and I now select only important features that are useful for my machine learning algorithm or deep learning algorithm. Okay, to my machine learning and deep learning algorithm, and using this selected deep learning machine learning algorithm, selected feature, you can say that it gives the maximum accuracy. Okay, so here I have to find the subset of features to optimize the certain criteria. Okay, so here I am using the subset of a feature. Out of this feature, I am to use the subset of the feature, and that to optimize my machine learning and deep learning criteria. Okay, so this is the first type where you have to select only the important you have to make the subset. So D is a subset of sorry, D dash is the subset of D. D dash is the subset of D. It means that this is the original data set and this is the newly developed data set D dash. Now, another method or type we are used to feature reduction, that is the type 2. It is form the original set of feature and create the new dimension with a small number of dimensions. Okay, so instead of going to that particular features, let us consider I have the 10 GB data. So out of that 10 GB data, I make another data set, okay, and it has volume, the small number of dimensions. Okay, and here I use only the 1 GB data. Okay, so instead of using the 10 GB, I am using the 1 GB of my data set, and that's why it is called the type 2 of feature reduction. Now, the third one, that is called the forward selection. What is the forward selection of feature reduction? In this forward selection, we have started with an empty set of feature sets and add one feature at a time. Then try each of the remaining features, estimate the classification or regression error for adding each feature, and select a feature that gives the maximum improvement and stop when there is no significant improvement. Okay, so what exactly means by this forward selection? So by the method of forward selection, what I am doing, I am selecting my first feature F1 and provide it to the machine learning model. Okay, and then check the accuracy. Okay, and when this accuracy, now let us consider for the one feature, the accuracy is only the 40%. Now what I am doing, I am adding the new feature, that is the F2, F1, then F2. Okay, and try again check the with ML model, and now I am increasing my accuracy, and now it is a 55%. Now F3, when you are adding the F3, okay, F3 is your next, right, and now it is a 65%. Okay, each time you have to select and give the check your feature estimate by adding the each feature and select the maximum improvement. Now let us consider you are adding the new feature, that is the F4, and once you are adding the F4, and now let us consider at the fourth stage you are getting the 89%. Okay, then you can stop. Then you have to stop because you are getting the maximum improvement. Okay, by adding the feature, so you finalize that. Okay, now I have to use only the 4 features for my machine learning algorithm, because these 4 features are giving me the maximum accuracy, that is the 89%. Okay, so this is called the forward selection. Now, opposite to the forward selection, there is another method that is called the backward selection. So what we are doing the backward selection? We started with a full features, means you have to use the full features and provide whatever the number of features it has, means if it is having the 100 features, 1 to 100, so you have to provide all these 1 to 100 features to the machine learning model, okay, and check the accuracy, and now let us consider the accuracy is 30%. Then you have to delete 1 and give the 99. When it is a 99, so it is a 35%. When it is a 80, remove it, all other, and give the 80. So let us consider it is a 39%. Then again remove all, and let us consider you have only the 5. Okay, so when it has the 1 to 5 features, we are selecting 1 to 5 features. So now the accuracy is 86%. So you can say that it's okay. Now, after dropping my all 95 features, I get the 86%, means that we are remain only the 5 features only. Okay, so in this way we are using a backward selection. Backward selection means we have to start with a full feature and then remain and remove the one by one, drop the one by one and one by one feature and then check your improvement. So this is a different type of feature reduction. Now, what are the methods are available for feature reduction? So for feature reduction, we have to use the filter method. For example, information gain is there, then the chi-square method test is there, correlation coefficient are there, then wrapper method are also available. For example, recursive feature elimination, genetic algorithm. So these are the some feature reduction algorithm. Then embedded methods, in the embedded method we can see the decision tree and all these things. Now, the selection of optimal feature or the correlation coefficient method. So there is another method we are used for feature relation, that is called the correlation coefficient method. So what exactly we are doing in a correlation coefficient method? So let us consider you want to find the correlation of attribute like A with a target attribute T. Okay, so this is one of the data set. Let us consider this is one of the data set, and in that data set there are how many features? There is a feature A, there is a feature B, there is a feature C, there is a feature D, and there is a feature E. And my target, what is indicating the target? So target is nothing but, let us consider I want to classify, is it a dog or is it a cat? So this is my target. Okay, I want to find out based on this feature the target attribute. Okay, is it correct or not? Okay, so what I am doing is find the correlation attribute like A with a target attribute. So first I am selecting the attribute A with my target attribute and check the accuracy. Okay, in the next step, this is the first step. Okay, now in the second step, what I am to do? I have to select the first and the second feature along with the target attribute. Okay, and I say that it is a model M2. Okay, and check the accuracy. In the next third step, now you have to add the A, B, and the C again in the list, combined with a T, combined with this target attribute, and provide to the machine learning algorithm called as a model M3. Okay, and check the accuracy. So you have to perform this A, B, C, D, E, all this, combine it. Okay, make a different model. For example, M1 model, then M2 model, then M3 model. What is this? This is a machine learning model. M4 model, M5 model, and so on. Okay, and find out the best model with your objective. Okay, so my objective, what is my objective? My objective was to select or to find out is the animal is a cat and a dog. So this is my objective. So I want to find out through this model, so it is a cat or the dog. So through this different model combination with the features, so you have to check the accuracy. So let us consider model 1's accuracy is 30%, model 2's accuracy is 35%, model 3's accuracy is 65%, model 4's accuracy is 85%, and model 5's accuracy is 87%. Okay, so you can select that 87 is a good one. Means you have to select all these 1, 2, 3, 4, and 5. All these 5 features to combine with the target attribute, and then you are getting the 87% accuracy, and hence you can select the best one. That is called the wrapper method. Now, what are the steps we have to use in a feature reduction? So basically there are the two features, two steps for optimizing using the optimization problem. So we have to use the optimization problem to optimize the feature reduction. Okay. The first one is called as a search the space of possible feature subsets. So in the first step, what you have to do? You have to try to make a subset. All of you now understand now what is the subset. So this is the this is the D, say that is your data set D, and from this data set D, you have to develop the one subset that is a D dash. Okay. So what is the difference between the D and D dash? In a D, let us consider there are the 100 features. So in a D dash, you have to use only the 1 to 10 features. Okay. So this is called as the D and this is called as the D dash. Okay. So in a first step, always try to develop the subset of your feature. So this is called as the subset of the feature. And in the second step, pick the subset that is optimal or near to optimal with respect to the objective function. Okay, so what is your objective? My objective is to classify the data or to clustering the data. So these are my objective, for example. So according to that, we have to pick up only that model that are near to this these subsets that are near to your object function. You are the same. Okay. Now, how we can use the different feature selection method? Okay. So there are the few methods we can use. For example, Pearson correlation coefficient, F-score, chi-square, signal to noise ratio, mutual information, etc. So these are the univariant that is look like the feature independently of each other. So in that case, we have to use these methods to select the features. That is the Pearson correlation coefficient, F-score, chi-square, signal to noise ratio, mutual information. So using this method, we can find out the best feature from your data set. Okay. Now we will see the first one that is more popular and more useful. That is the Pearson correlation coefficient. So how to use the Pearson correlation coefficient? So how we can find out the correlation between the two features? Okay. So aim of this Pearson correlation coefficient is to find out the correlation between the two features.